Hey kids, Flexing Teacher Weber here. I hope you're having a good day. So we've been working on algebra, and the last time we've been working with algebra, we've been taking math expressions and solving them by substitution to get another value. We're going to take that further today and start using that same idea when graphing. So this is what we did last time. Now what we're going to do today is we're going to start off with a math equation. So the math equation we're going to start off with in this one is y equals x plus 1. And we're going to complete the following steps. We're going to make a table of values. We're going to use positive and negative integers and 0 for values of x. And we're going to make 5 ordered pairs. So what we did is we made our table. And our left-hand column is x and our right-hand column is y. And we use the criteria from the question. We're going to use positive and negative integers and 0 for x. So let's keep it simple. For our negative integers for x, let's use -2, -1. It says we have to use 0. We have to use 0 for a value of x. And for our positive values, let's use 1 and 2. So that's how we started out. And then what we're going to do is we're going to use the idea of solving by substitution that we learned last time. We're going to take this math equation, y equals x plus 1, and we're going to insert the values for x to get the values for y. So I'll start off with y equals x plus 1. It's not a very good x. And I'm going to replace the x with -2. And -2 plus 1 is -1. So when x is -2, y will be -1. And then I'll do the same thing again. Y equals x plus 1. Y equals -1 plus 1. And y equals 0. So when x is -1, y will be 0. And then I'll do this again. Y equals x plus 1, and I'll replace the x with 0. Y equals 0 plus 1. Y equals 1. So when x is 0, y is 1. You can probably extend the pattern now. So we're increasing by 1 every time, right? I can even show this again. So this time y equals x plus 1. And I'll replace the x with 1 this time. Y equals 1 plus 1. And y equals 2. So when x is 1, y is 2. So you can see that the pattern is increasing by 1 every time in the y column. So we know here that when x is 2, y is going to be 3. And we've just used substitution to complete our table of values using this equation. Let's take it a step further now. The next question says, determine the value for y in the ordered pair -6y by using substitution. So we've been given, in this case, that the value for x is -6, but we want to figure out the value for y. So we're going to use our math equation. This is still the same question from here, so we're going to use this math equation. Y equals x plus 1, and we're going to substitute in -6 for x. And -6 plus 1 gives us a y value of -5. So that means when x is equal to -6, y will be equal to -5. Last thing we want to do now is we want to graph the ordered pairs from the table of values. So let's take the ordered pairs from our table of values. The first one was -2, -1. And let's write those properly. -2, -1. The next one was -1, 0. -1, 0. And then we had 0, 1. And 1, 2. And then 2, 3. Just double check those. Yeah. We also had the point -6, 5, -5 that'll be on this graph as well. So there's our ordered pairs. Now, you'll notice these ordered pairs have some negative values. So we're going to be using all parts of the coordinate plane when we graph this. So we'll go to our graph paper now, and we're going to be using all the parts of this grid. Previously, we'd just been plotting things in the top right-hand corner, but now since we have negative values, we'll be in all four what are called quadrants of the coordinate plane. Quadrant 1, 2, 3, 4. So our values are pretty simple values. They're pretty small values. So we can go up by ones on our axes. So where the x and y axis meet is 0. And I'm going to skip lines though and go 1, 2, 3, 4, 5. I'll keep going here, 6 and 7. And then below 0 on the x-axis, we keep that same scale. We'll go -1, -2, -3, -4, -5, -6, -7. And on the y-axis, we'll go up by 1. So 1, 2, 3. 4, 5, 6, 7, 8. It's about as far as we have to go. And then negative values. Below 0, we'll go -1, -2, -3, -4, -5, -6. I think that's probably good. So there's our coordinate plane with both positive and negative values. And now let's plot our points. So the first point was -2, -1. So just like before, we're going to go x first, so -2, then down to -1, and right where they cross, we'll put a point, call it -2, -1. And then the next one was -1, 0. So we'll go left -1, and we don't go down at all. We're right on the x-axis because it's 0 for the y. So we'll put a point there, call it -1 and 0. And then the next point was 0, 1. So we'll go nowhere on the x-axis, but we'll go up the y-axis to +1. Call that 0 and 1. And then the next point was 1 on the x and 2 on the y. So 1 on the x and 2 on the y, right there. Call that 1, 2. And the next point was 2 on the x and 3 on the y, right up there. So we'll put that point there. So 2 and 3. And then we also had that extra point, -6, -5. Now, let's do that one. Across -6 and down to -5 right here. And if you look at it, it still lies on that same line that we've created. So -6, -5. And what we have created is a straight line. We call it a linear relationship. And we could have points anywhere on this graph, so I'm going to join those points as best I can. Put arrows on the end indicating that this goes on forever in both directions. And we'll call this graph the equation y equals x plus 1. So that's a linear equation. It's a linear relationship. We call this thing a linear algebra equation because it creates a straight line. I'm going to do another video where we do another one of these equations where we graph these again, where we start off with an equation, we get some data, and we graph it. I hope that helps. That's all for now. Flexing Teacher Weber, out.